Have you ever looked up at the night sky, truly looked and felt a profound sense of wonder? Have you ever asked yourself the biggest question of all? Are we alone? This question isn't just for science fiction movies or late-night conversations. It is one of the most fundamental inquiries we can make as a species. It connects us to our earliest ancestors, who gazed at the same celestial tapestry, drawing pictures in the stars, wondering what lay beyond their reach. The universe doesn't just present us with points of light, it presents us with possibilities. Each star is a potential sun, a beacon in the cosmic dark that might warm a world we have yet to discover. The vast, dark canvas above is not empty, it's filled with untold stories waiting to be read. That velvet blackness, sprinkled with the diamond dust of distant galaxies' nebulae, is an invitation to curiosity. When you stare into that abyss, you are staring back in time. The light from some of those stars began its journey long before human civilization even existed, traveling across unimaginable distances to finally reach your eye. This simple act of stargazing connects you directly to the cosmos. Let's try to zoom out for a moment. Imagine you are leaving Earth, rising higher and higher until our blue marble is just a small sphere below. You pass the moon, you pass Mars, you keep going. Our sun shrinks to become just another star, indistinguishable from the countless others that surround it. You are now looking at our home, the Milky Way galaxy. It's a sprawling spiral city of stars, gas, dust. Our sun is just one resident among an estimated 200 to 400 billion other stars in this single galaxy. Think about that number. For every person who has ever lived on Earth, there are dozens of stars in our galaxy alone. It's a number so large it almost loses meaning. But the story doesn't end there. The Milky Way is not the only galaxy in the universe. It's just one member of a small cluster of galaxies we call the local group. Beyond that, there are superclusters, vast structures containing thousands of galaxies. As far as our most powerful telescopes can see, in every direction we look, there are more galaxies. Current estimates suggest there are something like 2 trillion galaxies in the observable universe. Now do the math. Billions of stars per galaxy, multiplied by trillions of galaxies. The total number of stars in the cosmos is simply staggering, likely more than all the grains of sand on all the beaches of Earth. For a long time we knew about the stars, but we could only guess if they had planets. Now we know. Kepler Space Telescope, James Webb Space Telescope. We have confirmed the existence of thousands of planets orbiting other stars. We call them exoplanets. The discovery of these worlds has revolutionized astronomy. It has transformed the question of other planets from a theoretical debate into an observational science. We are no longer just guessing, we are cataloging. This brings us to a simple but powerful idea in astronomy, the habitable zone. You might know it as the Goldilocks zone. It's that orbital region around a star where the temperature is just right, not too hot, not too cold, for liquid water to exist on a planet's surface. Here on Earth, liquid water is the essential ingredient for every form of life we know. It's the solvent where the complex chemistry of biology happens. So when we search for potentially habitable worlds, the first thing we look for is a planet in its star's Goldilocks zone. The size and temperature of the star determine where this habitable zone lies. For a hot, massive star, the zone will be much farther out and wider. For a cool, dim dwarf star, the habitable zone will be much closer in, planets orbit in weeks or days. With so many potential worlds out there, how can we start to estimate the chances of finding intelligent life? In 1961, an astronomer named Frank Drake came up with a way to think about this problem. He created an equation, now famously known as the Drake equation, to organize our ignorance. It isn't meant to give us a precise answer. Instead, it's a tool that breaks down the big question: how many intelligent, communicating civilizations are in our galaxy? Into a series of smaller, more manageable questions. It serves as a wonderful roadmap for the search for extraterrestrial intelligence, or SETI. The equation is a string of factors multiplied together. Let's walk through it. N equals R star times FP times NE times FL times FI times FC times L. It starts with the rate of star formation in our galaxy. Then you multiply that by the fraction of those stars that have planets. We now know that number is high. Next, you multiply by the average number of planets per star that could potentially support life, our Goldilocks worlds. From there, the equation moves into biology and sociology, where the numbers become much more speculative. You multiply by the fraction of those habitable planets that actually go on to develop life of any kind, Then the fraction of those life-bearing planets where life evolves: intelligence. After intelligence, there are two final crucial factors. The next term is the fraction of intelligent civilizations that develop technology capable of sending detectable signals out into space. This leads us to a deep and honestly kind of troubling cosmic puzzle. If there are so many potential places for life, and if life has had billions of years to get started elsewhere, then the universe should be teeming with civilizations. Some would be ancient, with technology far beyond our own. They should have had plenty of time to explore the galaxy, send out probes, or create cosmic signals so powerful they would be impossible to miss. Yet, when we listen, all we hear is silence. This contradiction is known as the Fermi paradox. Enrico Fermi famously asked, "Where is everybody?" There are many possible solutions, starting with distance. The galaxy is vast. While we haven't found aliens, we have found their potential homes, and they are stranger and more varied than we ever imagined. The thousands of exoplanets discovered have painted a gallery of weird and wonderful worlds. For instance, we've found hot Jupiters, massive gas giants orbiting extremely close to their stars. Their atmospheres can be boiled away into space. One famous example is HD 209458b. It may have clouds of metal with molten iron raining down, sizzling and glowing. Then there are super-Earths, larger than Earth but smaller than Neptune. 55 Cancri E is a standout. It orbits its star in less than a day. Its surface is blisteringly hot and carbon-rich. Under pressure, that carbon might be compressed into a layer of diamond, a planet-sized treasure chest. So, how do we actually search for intelligent life? We can't just hop in a spaceship and visit these exoplanets. They're light years away. Instead, we listen. This is the core mission of the Search for Extraterrestrial Intelligence, or SETI. If another civilization has tech similar to ours, they might use radio waves for communication. They might be using radar. Radio waves travel at the speed of light. They can pass through the gas and dust of interstellar space with relative ease. SETI projects use giant radio telescopes around the world, scanning the skies, listening for a signal that stands out from the cosmic noise. These telescopes are like giant ears pointed at the heavens. The most famous is the WOW signal, detected in 1977 by the Big Ear Radio Telescope at Ohio State University. For 72 seconds, the telescope picked up an incredibly strong narrow-band signal. It came from the direction of the constellation Sagittarius. The astronomer Jerry Amon circled the data and wrote "WOW" on the printout. It is crucial to be clear-eyed and scientific about this quest. As of today, September 3, 2025, we have found no definitive, verifiable evidence of extraterrestrial life, intelligent or otherwise. Unidentified flying objects, or UFOs, now called Unidentified Anomalous Phenomena, or UAPs, are just that, unidentified. They are not confirmed alien spaceships. An unexplained phenomenon is not proof of aliens, it's simply a mystery waiting for a solution. In science, and especially in a field as profound as this one, we must adhere to the highest standards of evidence. As the great scientist Carl Sagan said, "Extraordinary claims require extraordinary evidence. The burden of proof rests on those making the claim." If someone claims to have found an alien signal, the scientific community will demand independent verification by other observatories. It must be persistent, or at least repeatable. This is not about being cynical, it's about being rigorous. So, where does that leave us? We are in a remarkable moment in human history. We stand on a small world, looking out into a vast cosmos filled with countless other worlds. We have developed the tools to listen for our cosmic neighbors, and we've begun the search in earnest. We are armed with the Drake equation as our guide, sobered by the Fermi paradox, inspired by the gallery of strange new worlds our telescopes have revealed. We have not yet found what we're looking for, but the search has only just begun. In cosmic terms, we've just dipped our toes into the ocean. This quest is a testament to one of the most noble human traits, our insatiable curiosity. We are a species that looks up. We ask questions, we explore. We're not content to simply live on our world, we want to understand the universe and our relationship to it. The search for extraterrestrial life is the ultimate expression of that exploratory drive. It connects us to a long tradition of explorers, ancient Polynesians who navigated the Pacific by the stars, to the astronauts who first stepped onto the moon. We are reaching out, not with ships, but with our intellect and instruments. The discovery of life beyond Earth, in any form, a microbe on Mars' vegetation, on an exoplanet, a signal from a distant star, would change everything. It would reshape our science, our religions, our philosophies, and our entire conception of ourselves. It would provide a definitive answer to that ancient question and prove that we are not alone. It might usher in a new era of cosmic awareness, helping us to see our own planet as a single, precious home for life in a much larger living universe. It might even help us to appreciate the bonds we share with each other as fellow inhabitants of this one known living world. Until that day comes, we will keep looking. The truth is out there, waiting to be discovered.